The Elimination Method, brought to you by Pirates of the Caribbean Lego Zombie Guy with Sword. This is actually my favorite method. I prefer this. It always feels like less work. Either method works. Graphing always works too. Um, this is slightly different. You can read that. Whatever. I'm just going to demonstrate it. What we do is we write out both equations in a, we call this as a stacked fashion. And so you line up the variables and the constants. If they're not in this standard form, this ax plus by equals c, you would want to kind of rearrange them so that it is. And then our goal is to add these two equations together in such a way that the x's or y's cancel. So in this case, since these coefficients are not opposites, neither of them, we have to multiply these equations by some constant so that they become opposites. So I'm going to multiply this equation by -3 and this top equation by +2, because 2 times 3 is 6. -3 times 2 is -6. And when I add that, we would get 0 y's left in our expression. So we'll rewrite these new equations. 8x plus 6y equals 22. You might be asking yourself, how is it that you can do this? And I'll remind you that when you multiply both sides of the equation by something, we have changed absolutely nothing. Right? These two equations are the exact same equation as that. They just have coefficients of a different magnitude higher, right? So now that we have opposites, in other words, these two have opposite coefficients, we simply add the equations together. By the way, if they were not opposites, if we had 6y and 6y, then you'd subtract. The only reason I don't like doing that is when you subtract, you have to make sure you subtract each term, which means you have to change the sign. When you're adding, you don't change the sign. So here I get 8 plus 15, feels like a solid 23x. And here I get 22 minus 45, feels like a solid -23. What? Who did this to us? This is an engineered problem. We get x equals -1. That's a nice, beautiful, clean solution. What? No, it's not a solution. That's half of it. We need the y value. So we could repeat this exact process, and we could just multiply by 5 and 4 and do the whole thing. I think it's less work to take this -1 and use what we did back with substitution. Plug it into either of these two equations, or any equation on the page here. I'm just going to pick this -5. I don't particularly have a reason. Maybe it's because it makes the 5 positive, and so then I'm going to add 5 to both sides, and I get 2y equals 20, and so I divide both sides by 2, and I get y equals 10, but I don't know. So there's your solution. Note, this is a independent, consistent system because these equations are different, and we have at least one solution. Just for fun, let's show. No, we don't need to see this graphically. You all got that, right? All right, one more. What do you want to guess that this is a consistent dependent system? Who knows? Okay, so I'm just going to glance at these and note that this 2 times 2 equals 4. So when I rewrite these, I'm going to multiply this by -2. So I'll have -4x minus 6y equals -12. And then this other equation is 4x plus 6y equals 12. What? Do you see what I see? They're the exact same equation. Note what happens when I add. The left side becomes 0, the right side becomes 0. That means any ordered pair that is a solution to this equation is also a solution to that equation. So this means we have infinite solutions. All you do is pick an x and plug it in, and you get a y, or pick a y, plug it in, you get the x for either one of the two equations, and away we go. This is a consistent system because there is at least one solution. Yeah, there's like infinite, but whatever. And then it's dependent because they're exact same line. This one I am going to graph just so you can see. Oh, look, the last video is uploaded. So let's just plug these two in. I'm going to type these, the first ones, the ones before I multiplied by 2. because they didn't look the same unless you were paying close attention. The first equation was just a multiple of 2 of the second equation. Oh, look at that. Ooh, 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 same line. Okay. Well, I guess that's the end of this video.